welcome to the San Marcos Wastewater Treatment Plant. We are located just 30 minutes south of Austin, Texas. This is episode 1, Intro to Wastewater, or as I like to call it, episode 1, The Wastewater Menace, for you Star Wars fans out there. My name is Andrina Salas.
And I'm Arisbeth Cordova.
And we'll be your 2 hosts for these vlogs, so be sure to subscribe and comment below if you have any questions throughout the vlogs, and we'll have new episode out once a month. I am the lab supervisor here, and I've been out here for 4 years now. I graduated from the University of Texas at Austin with a biology degree, and I would have never thought that I would have a career in wastewater treatment, but I have a passion for science and sustainability, and I knew I didn't want to necessarily go into a career in medicine, and I actually stumbled upon an internship at this project site in San Marcos. And 4 years later, I can honestly tell you I've loved every bit of it.
I'm the new operator in training. I was a former intern here this past summer. This is my supervisor. I recently graduated from Texas State University with a major in resources and environmental studies. Now, because of this pandemic, I was unfortunate enough to not have a graduation ceremony, which really sucked. So for your former graduates, I feel your pain. But I'm very fortunate that at the end of the day, I was able to find a full-time position through these hard times. And I'm very thankful for that. And especially to work here at Jacobs, I think that's amazing.
So as you can see, we have this glass partition between us. We're wearing face masks. And out in the field, you'll see our other full PPE that we're required to wear for our safety. So bear with us. It'll be a little hard to hear us at some points, and you can't read our lips, and we're separated a lot of the time. But we'll make this as virtually interesting as possible. The purpose of the vlog is to educate the public about the wastewater treatment process and eliminate the stigma associated with wastewater. As a result, again, of the ongoing pandemic, we've conducted live virtual tours in the past for Jacob's summer internship program and Texas State students that are just down the street in place of the regular in-person tours. And due to the success of these virtual tours, we had the idea to start this vlog that's readily accessible to anyone and everyone at any given time. So this first episode will introduce our facility and gives a simple overview of the wastewater treatment process. And each subsequent episode from now on will focus on each treatment step in more detail. And later we're going to dive into sampling events, sustainability projects, day-to-day operations, and maintenance at the facility. So a little bit of background about this project site. We've operated this facility for 16 years now, and the plant has a capacity of 9 million gallons per day, or 9 MGD, but we roughly treat about 4 to 5 million gallons a day. So to get started, let's go meet our project manager, SHROPSHIRE.
Hi, I'm Paul SHROPSHIRE, the project manager here in San Marcos at the City of San Marcos Wastewater Treatment Plant, and look forward to seeing all of you one day here in person. But until then, this virtual tour should be very sufficient.
So you got to meet our project manager. You'll meet everyone throughout the other episodes. They're out in the field right now. We got our assistant project manager out on paternity leave, and you'll meet him eventually too. He's a microbiologist, so when we go into that in a later episode, you'll get to meet him as well. But for now, we're your 2 hosts for the remainder of all the vlogs. This is going to be our baby, so get used to us. Thanks, Paul.
Thanks. You'll enjoy.
So now we're going to give a rough view of the inside of the admin building. Like I said, everyone is out working already, but we're going to give you a view of our operations room and the SCADA room. So this is just going to be a rough view of things. And again, we'll go into everything in more detail in a later episode. This is kind of just an introductory to our facility. And for those of you who have never been to a wastewater treatment plant or know what wastewater entails, we'll give you all that today. So these are all our automatic controls, all our lift stations. Lift stations are basically pump areas that take all the water that come from the residential areas. University, Texas State University is here in San Marcos, Texas, and all the other restaurants in the area. All the water that goes down the drains goes to the local lift stations. The lift stations all pump to 2 main lift stations, main lift station and Cottonwood lift station, and then they all get pumped to our headworks, which will go check out later and then pump through the rest of the treatment process. So let's go on.
So every morning I come in and I calibrate all of the instruments and I report it here in our calibration log. I spend majority of my day here sampling a lot of the water from each step of the process just to monitor the water quality before it's discharged into the San Marcos River, because we want to make sure that we're not adding any pollutants into the river and we're doing our job. All right, let's head to the conference room and get this store started.
Conference room. I'm going to give y'all a quick overview of our treatment process via this drawn out diagram. So basically our influent water comes in first through the headworks and then we'll run through the bar screen and the grit chamber. The purpose of this physical process is to take out all the rags and toilet paper and grit and sand that may come through the water, and then that will be dumped in a dumpster and hauled away to the landfill, and the rest of the water will continue on to the system to continue the treatment process. After it goes to the bar screen and grit chamber, the water will continue to the primary clarifier, which is another very physical process. The solids will drain to the bottom and get pumped out to the solids holding tank and will get processed in the centrifuge and get hauled away to the landfill. And we'll go into biosolids management in a different episode because some facilities will use their biosolids and convert it to fertilizer. Unfortunately, at this facility, right now we just haul it to a landfill. So from the primary clarifier, water will go into the aeration basin. We have an anaerobic zone and then 4 zones, and we have an identical side with another anaerobic zone and 4 zones. So the purpose of the aeration basin is our little microbiology environment that we build and maintain to treat the water biologically and to meet our permit requirements. So for example, our phosphorus limit is 1 milligram per liter. And if we get close to that limit, then we add ferric chloride, our chemical, but we try not to add the chemical unless absolutely necessary. What we try to do or achieve is biological nutrient removal or biological phosphorus removal via the organisms that are already present in the wastewater. And this is the area in which we try to do that. So after the water gets treated and the phosphorus and other nutrients are removed from the aeration basin, the microorganisms will move on to the secondary clarifier, and those microorganisms and leftover solids will get wasted out in this area here, very similar to the primary clarifier, and it will get pumped in back to the solids holding tank. But the only difference in the secondary clarifier, the other half of the solids will actually get returned back to the aeration basin to keep our bug or microorganism population alive, so we can continue doing our biological nutrient removal or biological phosphorus removal process. So from the secondary clarifier, after the solids have been removed, the water will continue again to our same filter or tertiary filters. So if any of you have any fish at home in a fish tank, you probably use carbon filters. It's a very similar process. We use anthracite and sand to filter the water to get those fine microscopic particles out, so then we can disinfect it via UV light. So the sand filter is a gravity system. The water will drain through the anthracite and sand downward, get backwashed, the dirty water out, and the backwashed water will return to the front of the plant and the treatment process will start again. The rest of the filtered water will continue on to the UV disinfection system. It will get blasted with UV light, just like a tanning bed. So the water is getting a tan, and the pathogenic organisms and their ability to reproduce will be cut. And then it will continue on to the re-aeration basin, where we add dissolved oxygen via diffusers. And then we hit our final effluent and then discharge into the San Marcos River. As you'll see later in the video, when we go outside, you'll see the San Marcos River and all the fish and wildlife that are present around the facility and in San Marcos. So we also produce what's called reclaimed water or reuse water. So before the water goes to be UV disinfected after the sand filter, some will be pumped out separately to be disinfected via sodium hypochlorite or really strong bleach. After the reclaimed water is disinfected with sodium hypochlorite, then it's ready for distribution around the city. We also use the reclaimed water here at the plant. So now, after I give you this overview of our treatment process, let's go ahead and head outside and show you the actual facility. Welcome to the headworks, and forgive me, I'm a little out of breath and out of shape. We have to come up 2 flights of stairs to come up to the headworks, which is where all the influent water comes in. So our treatment process basically is gravity fed, which is why we're at the highest point of the treatment process, and the water flows downhill gradually until the final treatment process. So basically the purpose of the headworks, if you want to follow me, my camera lady, Elizabeth, of course, are screens, grit chambers. Again, we'll go into further detail in later episodes. Again, leave comments if you have any questions. We can address it on the next episode or the next time we touch on that treatment process. So basically just think of a giant mechanical rake removing rags and grit. So this is the bar screen. So it's not running right now, but basically it's a really fine rake, and this will go down, pull up all the rags and dump it over the edge and down into the dumpster. Again, it's like a giant mechanical rake. We have our grit chambers, which remove all that fine grit or sand that comes in, whatever you may flush down the drain. And I would also like to note a few things. You should not flush down the drain. Everything except toilet paper. Literally. Please do not flush flushable wipes. They are not flushable. They do not break apart. And you'll see why. On our next episode, we'll go into further detail about how the headworks really work. But just to give y'all an idea, after the rags and the grit are removed from the water, they come and dump in this giant dumpster. So just to give y'all a quick view of what goes down the drain, people will flush spoons, condoms, tampon applicators, Pop-Tart wrappers, you name it. It's ridiculous. That should not go down the drain. That should go in the trash can, people. This is another reason why we're trying to do this vlog. Educate the world. Please don't flush anything except toilet paper.
Where we start our first part of the physical treatment here. Now, once the water passes through the bar screen and the grit chamber, the water is sent towards the middle of the basin, where it will pass through the feed well, and then it will be dispersed throughout the entire tank. We try to do this to slow down the velocity of the water to allow that material to settle at the bottom of the basin or to float. Now we have mechanical equipment that will scrape the surface of the water to take all that floatable material and drop it into that skim box. And parallel to that, we have another rake arm that will gather all of the solids from the bottom of the tank, and then it will be all wasted out and sent towards the solids holding tank.
The aeration basin where all the biology happens, and again we'll give you a quick overview of how this process works. So step number 1, coming from the primary clarifiers, you enter the anaerobic zone. So as you can see, there's no air being sent to this zone, which means it's anaerobic. Zone 1, first stage with air. This is our aerobic zone, zone 1. Then we have zone 2, zone 3, zone 4, and there's 2 identical sections with zone 1 through 4 on either end. And essentially, as it goes throughout the process from the anaerobic zone to zone 4, we're removing phosphorus, either biologically or if necessary, we add ferric chloride. But we only do that if absolutely necessary. And if you have any questions on the process, please comment below. So now, as you just saw that waterfall, this is zone 4, the last treatment stage in the aeration basin. Then it will go on to the secondary clarifier. And also at zone 4, where this waterfall is, to the next treatment stage, is where we add, if necessary, ferric chloride to remove phosphorus to meet our permit limit. Our permit limit is set at 1 milligram per liter, and we constantly keep it well below that. Secondary clarifiers. Here at the San Marcos Wastewater Treatment Plant, we have 3. So this is one of 3, very similar to the physical process that goes on at the primary clarifiers. However, by this point, after the aeration basin, it's a lot cleaner. So the solids that are settling at the bottom of that cone that you saw on the drawing is doing the same thing. Going to, when we waste it out, it's going to that blue solids holding tank, or in this case, the other half is either being wasted, like I said, or returned, known as return activated sludge, back to the aeration basin to keep our microorganism and food and bug population healthy and alive, so we can continue that biological process I was telling you about, which we'll go into detail in later episodes. But as you can see here, very similar process. The water comes in through the middle, the velocity slows down, as Arisbeth was saying, and all the solids settle. There's a scum arm that rakes the very top of the water and dumps into a scum box, and then gets returned to the beginning of the plant to continue the treatment process. So I hope y'all are enjoying the mini tour so far. Like I said, all of the treatment processes that we're showing you today, we'll go into way further detail on later episodes. But now we're at our filter building, and we're just outside of it because it's very, very loud because of the waterfall and all the water inflowing from the previous process. So like I was saying when we were in the conference room, in the filter building, there's 3 filters that are going on and backwashing all the dirty water that filters through the bottom, through the anthracite and the sand. So basically when it comes in, it goes and filters like this through the anthracite and the sand, and all that dirty water is getting backwashed, and all the clean water continues through the system. So it's a very simple physical process, but very important to minimize the turbidity right before it goes into UV disinfection. So on this next little clip, you'll see what the filter building looks like.
passes through the sand filter, it will go towards our UV light disinfection. This will kill the pathogenic organisms from mutating or reproducing later on after this treatment. The light bulbs are submerged into the water to make sure that it's killing anything that's passing through. Alright, y'all, we're down at the river, and y'all are so fortunate you were able to see the cows on the other side of the bank come down from the fish hatchery to drink water. We were so excited to see them, and so excited that y'all were able to see that. It's really rare when you get to see them during the daytime when we're working, but it's really beautiful down here. And this is exactly where we discharge into. I don't know if you can hear them in the background mooing. Gorgeous. This is really a wonderful area. And we discharge into this river. Clean water. You can see straight down through the bottom. It's home to Texas wild rice and 3 other kinds of endangered species, including the blind salamander. A lot of stuff goes on here, and we're really proud to be part of this operation and discharge into the San Marcos River. Look at those cows. This is wonderful. We're so glad you guys could experience this with us. So stay tuned for our next episode. We'll go into the headworks and what all that entails, and then we'll go on from there in each treatment process. And any questions y'all have along the way, be sure to subscribe and comment on our videos below, and we'll be sure to address them on the next ones. We'll see y'all next time.